Welcome. Thank you for joining us for today's webinar, Maximize Productivity and Minimize Costs with New Aerospace Structural Adhesives, presented by Huntsman Advanced Materials and TechBriefs Media. I'm Bruce Bennett, editor at TechBriefs Media, and I'll be your moderator today. This webinar will last approximately 60 minutes, and there will be a question and answer period at the end of the presentation. If you have a question, you may submit it at any time during the presentation by using the Ask a Question box on your screen. Our speakers will answer as many questions as possible at the conclusion of the presentation. Those questions not addressed during the live event will be answered offline. You may also download a PDF of the presentation slides under the Event Resources tab on the left of your screen. To view the presentation properly, please disable any pop-up blockers you may have on your browser. At this time, I'd like to introduce today's speakers. Todd Holder manages the Aerospace Adhesive Distribution Network for North America and direct accounts for aerospace OEMs and tiers. He has 31 years of experience in various aspects of both the commercial and defense aerospace industries, including sales, marketing, and training. Todd has developed performance requirements for new product innovations and coordinated the testing and certification of numerous products to various aerospace specifications. Lee Eleuterius works as the technical service scientist for adhesives. Over his career, he has worked with thermoplastics and thermosets in the areas of extrusion, composites, and adhesives. Lee received a Bachelor of Science in Polymer Science from the University of Southern Mississippi. Now that you're familiar with our speakers' qualifications, let's begin today's presentation.
Thanks, Bruce, and thank you to everyone who's joining us for today's discussion. We appreciate your time. As you may know, the aerospace industry is currently under increasing pressure to reduce production times and drive out costs from all aspects of both their supply chain and manufacturing process, or cost-out initiatives, as they're known by many of you. If you think about your current situation, you may be either looking to improve performance in a new design you're working on, or you're under existing contracts with fixed pricing and deliverables, and the best way to increase your profit is by driving costs from your production process. The aerospace adhesives we're going to be discussing today can help you to reduce these overall cost goals. We can also improve your productivity goals by improving efficiency and throughput, and also by helping to simplify your materials inventory, all while helping reduce aircraft weight and extend part lifetimes. We'll be discussing 3 new structural adhesives from Huntsman to help these aerospace engineers and supply chain teams to meet their challenging cost reduction demands. Our Epibond 215, Epibond 300, and Epibond 200 are easier to use and offer faster handling and curing times than many currently offered products. So what do we do at Huntsman Advanced Materials? Well, we make things possible. Huntsman Advanced Materials serves many of the world's leading businesses across countless industries. We enable greater innovation, performance, and sustainability to engineering challenges on a global basis while contributing towards a better quality of life. We focus on specialty resins and formulated systems, including epoxy resins, multifunctional components, adhesives, and core reinforcing materials. One of the things that makes Huntsman unique in this industry is that we actually synthesize our very own base components and building blocks as well, versus having to seek these out from other suppliers. Huntsman's aerospace legacy dates back well over 70 years to when one of our earliest adhesives was used in the fabrication of the de Havilland Mosquito, better known as the Wooden Wonder to many of you. It was powered by 2 Rolls-Royce Merlin engines. Its innovative design made it the fastest operational aircraft in the sky in 1941. The Mossy served successfully in both bomber and fighter roles during World War II. From this great aviation legacy, our current aerospace brands include Aerolite, Epibond, Epicast, and Urolane. Our products are used on almost every major flying platform today. We're specified by manufacturers producing commercial airliners, general aviation, military aircraft, and spacecraft throughout the world, and we're qualified to well over 100 various OEM specifications. Okay. In case you're not completely familiar with Huntsman Advanced Materials, I'd like to share with you that we operate production and technology facilities in the Americas, Asia, and Europe. As a global manufacturing leader, our sites are focused on quality, efficiency, and especially safety. They range from smaller facilities designed for specialty production to world-scale production plants, ensuring supply to customers with global requirements. Our capabilities in high-performance adhesives and composites are made possible by more than 1,600 associates worldwide who help support our over 2,000 global customers with innovative, tailor-made solutions and more than 1,500 pioneering epoxy, acrylic, phenolic, and polyurethane-based polymer products. Now, as we start to review what these new adhesives offer, I encourage you to think about your current and future designs, your current production processes, and the challenges that you're being tasked with by your management. We want to help you achieve your company's goals and to break up, the status quo, so to speak. So as you think about how we may be able to help you improve these challenges over the next few minutes, please take a moment, make a few notes, and if you're comfortable reaching out to ask some questions during today's discussion, we encourage you to do so, or you're certainly welcome to drop us an email once this is over. Now what you've been waiting for, our first adhesive. The newest addition to our aerospace adhesives family is already under qualification by two of our customers. Epibond 215 is the first structural adhesive we're going to discuss today. Thanks to its overall mechanical performance, Epibond 215 has up to 45% better peel, shear, and compressive strength than many of the competitors in the same class of adhesive. Thanks to these features, Epibond 215 can actually replace up to 5 competitive adhesives and is actually approximately 75% lighter weight than your traditional mechanical fasteners that you may be currently using. What all this means is that you may be able to reduce your inventory SKUs by up to 80%. So if you think about the advantages of these adhesives over mechanical fasteners, they're not only lighter weight, there's no drilling of holes, which greatly helps reduce potential for points of corrosion, and especially the really horrid headache of misdrilled holes. All this means greater corrosion resistance, lighter weight, and improved production and inventory efficiencies. Now I'll turn it over to Leah Yaterius for a more technical look at our Epibond 215.
Thanks, Todd. Epibond 215 is ideal for bonding multiple substrates, including metals, composites, and most thermoplastics. What you see here on the left is an overview of the performance data. The primary feature of Epibond 215 is its exceptional peel strength. At room temperature, it gets 85 pli for roller peel and 71 pli for T-peel. Now, typically, adhesives with a high peel will suffer from reduced lap shear strength, especially at elevated temperatures. But for Epibond 215, while it has high peel, it also has exceptional lap shear strength at room temperature, as you can see, 5,200 psi. It also has a wide service temp range from -90 F to 250 F. At 250 F, the lap shear strength is 2,000 psi. While most epoxy adhesives have a decline in performance at extremely low temperatures due to embrittlement, the lap shear strength actually improves to 5,500 psi at -90 F. Combined with its low outgassing, this product is well suited for space applications. It also maintains a good compressive strength of 7,400 psi at room temperature. And as a side note, you can contact us and request any additional data that is not shown in this presentation. If you look to the right side, the strength build during cure is shown. If you look at the dark line, which shows the room temperature cure, it has a generous open time followed by a relatively rapid build of handling strength. It will reach over 3,000 psi in 5 hours. This will allow the bonded assembly to be moved within one shift, improving production throughput. It will be almost 90% cured in 24 hours. So think about it. With that long open time, you can perform more bonding operations or bond larger parts, yet the work can be completed within one shift due to its strength build. Of course, an accelerated cure can also be used. If you look at the gray line, it will reach full cure in 1 hour with an elevated cure of 158 after 3-hour gelation at room temperature. Next slide, please. In this bar chart, we're showing Epibond 215 compared to several competitor adhesives designed for similar applications. These applications are primarily sized by peel and shear strength. We are comparing data across all performance values: T-peel, roller peel, and lap shear strength at room temperature, low temperature, and elevated temperature. Now, The point of this chart is to show that EpiBond 215 can functionally replace all of these other competitor adhesives, plus any other specialty adhesives designed for single performance characteristic. So, for example, if you look at the bar chart, competitor number 2 has a good lap shear strength at room temperature and low temperature, but the roller peel is average. For competitor number 5, it has a very good roller peel, but the lap shear strength is very low. Or competitor 6, its lap shear strength is quite good at high temperature, but the peel strength suffers, as does the low temp lap shear performance. You can see that EpiBond 215 maintains excellent performance across peel and lap shear values from low to high temp. Now, how can it improve productivity? Well, the time to handling strength for several of these competitor products is 12 to 24 hours. EpiBond 215 reaches handling strength in 3 hours. So, unlike the competition, EpiBond 215 will allow the part to be moved in one shift. In summary, you can have a high peel, high lap shear strength, wide service temp, and improved production throughput in one product that can potentially replace several competitor products. Next slide.
All right, thanks, Lee. Suitable applications you may want to consider EpiBond 215 for include the bonding of not only simple fixtures, brackets, mounting posts, inserts, and nut plates, but all the way up to major airframe components such as your spars, ribs, stringers, and even flight control surfaces. Thanks to the low outgassing that Lee pointed out, it's also a great option to consider for space applications, including component and insert bonding. When we formulated EpiBond 215, it was based on extensive customer feedback. As a result, it's capable of replacing up to 5 adhesives in the same class that are on the market today. When you're thinking about your operation, be sure to keep in mind that when multiple adhesives are used in the same assembly, both production time and inventory complexities can grow significantly, along with product application, EHS, and training requirements. So why make operations more complicated than they need to be? Straightforward, EpiBond 215 is a high-performance structural adhesive with exceptional peel strength and shear strength across a wide variety of temperatures. Next up, one of my also favorite adhesives, EpiBond 300. EpiBond 300 is a very versatile and impressive structural adhesive, and it can actually improve your production throughput by up to 80%. EpiBond 300 features an up to 80% quicker time to handling strength and even an 88% faster cure time. What this means is that depending on the size of your application and your part assembly, your operations could be completed and moved within a single shift and a fully cured part produced within 1 day. EpiBond 300 offers high compressive strength along with high service temperature. It thus enables it to be suitable for a very, very suitable candidate for use in liquid shim applications where you may currently use metal shims. With EpiBond 300's high elevated temperature performance, improved handling and flexible cure times and cycles, it's better than many products currently in the market today. So be sure to note the differences that Lee is going to point out to you about how this material handles, its compressive strength compared to older products on the market, and also its impressive peel strength. So Lee, if you could share some technical information with us.
EpiBond 300 is ideal for high volume production for applications requiring high strength at elevated temperatures. The primary feature is exceptional mechanical properties and strength retention of those properties at high temperatures. On the left, we're showing compressive strength and lap shear strength values at room temperature and elevated temperatures. It's very strong in compression, giving 11,000 psi at room temperature and 9,000 psi at 250 F. Another additional benefit is the compressive failure mode. I've personally observed that EpiBond 300 will not shatter when it fails, unlike the competitor product. For lap shear strength, it gives 4,200 psi at room temperature, 3,100 psi at 250 F, and it retains 1,100 psi at 400 F. That is outstanding adhesive performance. EpiBond 300 also cures at room temperature. If you look at the right side, you can see that the handling time at room temperature is slightly over 4 hours, which enables completion of assembly within one shift. And, as indicated by the circle, it will achieve 85% cure in only 6.5 hours. If you want to speed things up, 1 hour at 150 F will give a full cure. EpiBond 300 is available in dual barrel cartridges and pail kits. For this class of adhesive, some competitors are only available in injection kits. This allows for versatility in application by cartridge, hand mixing, or meter mix dispensing. Next slide, please. What we're showing on the top is EpiBond 300 compared to the leading competitive liquid shim adhesive for aerospace applications. These applications are sized by compression and lap shear strength and high temperature performance. Lap shear and compressive strength at room temperature is similar to the competitor, but at elevated temperatures, as you can see, this product far outperforms the competitor. At 400 F, the lap shear strength is significantly higher, doubling that of the competitor. The compressive strength is also significantly higher at 250 F, again, almost doubling that of the competitor. The T-peel for EpiBond 300 is 3 times that of the competitor. So, when comparing performance across all characteristics, especially at high temperatures, EpiBond 300 is not only a superior liquid shim, but an outstanding structural adhesive. Compared to the competitor, you can also achieve a significant cost reduction using EpiBond 300 due to its processing characteristics. You can see on the bottom half of the slide, EpiBond 300 reaches handling strength in 4 hours at room temperature, whereas the competitor will take 24 hours. Yet, in under 24 hours at room temperature, EpiBond 300 will achieve full strength. The competitor will take up to 5 days. So, in addition to high performance, this product offers increased productivity. Next slide.
Thank you, Lee. So as Lee just pointed out, the 300 is well designed for a variety of demanding applications where an adhesive or liquid shim may be needed. This is anything from skin to structure, engine to cells, and other environments requiring a high service temperature product. EpiBond 300 is a smart choice for your consideration. Along with the unique compressive characteristics, it has excellent compressive and shear strengths, offers a much greater peel strength than other options on the market, and to keep your team in the shop happy, we're talking about the people who actually have to mix and handle it and apply it. The 300 has a much more user-friendly mix ratio and a more similar resin and harder viscosity, as well as flexible curing options. This similarity in viscosity really helps to improve safety concerns when they're mixing it, as it reduces the potential for splash to the user. Next up, one of my absolute favorite adhesives that we're introducing. It's EpiBond 200. EpiBond 200's structural adhesives, faster time to handling strength, can increase your throughput by up to 50%. This could allow your parts to be completed in one shift. It's very flexible, it's very tough, yet offers high shear and good performance across a wide temperature range. One of the many things I like about the very versatile EpiBond 200 is how well it flows and wets out, yet it's also non-sag, which allows it to be applied vertically or overhead. So if you think about your shop, this means that the shop wouldn't have to rotate the tooling jig or the part during production. Adding to the list of things that make me like EpiBond 200 so much is the simplistic mix ratio. It's very straightforward, either 1-to-1 by either weight or volume. Again, this speaks to its shop-friendly handling characteristics. Also, in areas where the bond line may be exposed to dust or FOD in the shop, the faster tack-free time reduces the potential for contamination. So back to Lee one more time for a technical review of EpiBond 200.
Thanks, Todd. As he said, EpiBond 200 is ideal for aerospace structural bonding requiring vertical or overhead product application due to its non-sag rheology. An overview of performance data is on the left. Its primary feature is excellent mechanical performance at elevated temperatures while remaining flexible and tough. At room temperature, the lap shear strength is 3,200 psi, and at 250 F, a little over 1,000 psi. EpiBond 200 gives good performance at low temperatures as well. Typical competitive products either become too brittle or do not have good strength retention at lower temperatures. But EpiBond 200 has a lap shear strength of over 3,100 psi and negative 67 F. So as far as processing goes, it's easy to mix and dispense and has a 60 to 70 minute working time. It will be FOD tack-free in 5 to 8 hours at room temperature and reaches handling strength in 6 to 8 hours at room temperature. It will be fully cured in 7 days at room temperature, or it can be accelerated for 2 hours at 150 F after application, or only 1 hour at 150 F after it reaches handling strength. Next slide, please. What we're showing here is EpiBond 200 compared to the leading competitive flexible adhesive used primarily as an edge sealer. This is primarily sized by toughness and high temperature performance. It has excellent mechanical strength compared to the competition, especially at elevated temperatures. Here you can see that while the T-peel and lap shear strength at room temperature is similar, you can get about 150% improvement in strength retention at elevated temperatures. You can also achieve a significant cost reduction using EpiBond 300 due to its processing characteristics. EpiBond 200 reaches handling strength in 6 to 8 hours, whereas the competitor time to handling strength is 8 to 12 hours. This means that you can get a 30 to 50% increase in production throughput. EpiBond 200 will allow you to complete an assembly operation within a single shift. Back to you, Todd.
Thanks, Lee. I appreciate the excellent insight. As you can see from what Lee pointed out, EpiBond 200 is certainly a good candidate for a very broad range of applications such as fixture mounting, insert potting, nut plate, and component bonding, and also for high fatigue applications and even edge sealing of areas such as CFRP and other composite materials where you may want greater strength and durability beyond what simple sealants may offer. EpiBond 200 is a very versatile, flexible, and high-performance structural adhesive to consider. It's going to help you improve productivity. It's non-sag. Its elevated temperature performance and improved cure schedule are all user-friendly and design-friendly attributes. So, in summary, Huntsman's EpiBond structural adhesive line offers improved performance across a wide variety of demanding ranges in the aerospace applications. The 3 products we presented today will help aerospace supply chain meet the demanding and challenging cost reduction that we're faced with in our industry. Our easier to use, faster curing products enable our aerospace customers to reduce their overall production cost and improve product productivity and throughput. EpiBond 215 is a high-performance structural adhesive designed for high peel and shear applications like primary structural bonding. It can also replace many currently competitive products and replace the use of mechanical fasteners as well. EpiBond 300, with its exceptional compressive performance and strength at higher temperatures, is ideally suited for applications such as liquid shim and other structural adhesive applications, while also providing significant improvements in your productivity and your throughput. Finally, EpiBond 200 enables easier application and improved throughput for a variety of applications. Its excellent mechanical performance, flexibility, and toughness make it ideal for fixture mounting, insert potting, edge sealing, and other demanding structural applications with vibration and repetitive promotion loads, such as flight control surfaces. So as we share this information with you today, I hope you thought about some of the specifics of your unique application, your needs, your wants, your concerns, and your future plans. Please reach out to us if you think we can help, or even if you only have a simple question. Remember, we make things possible. In addition to these products that we just discussed, Huntsman Advanced Materials offers a wide range of void filling and core reinforcing compounds, edge fillers, structural adhesives, and laminating resin systems. Additional technical information and samples are available by reaching out to us through the contact form located on our website at www.huntsman.com/aero. So thanks again for attending today's presentation. Let's open it up for some questions.
Thank you, gentlemen. Before we get into the questions, I would like to remind our attendees that they may submit a question simply by using the Ask a Question box on their screens. Okay, let's get into the first question. What kind of substrates did you test, and what was the surface preparation?
That's a good question. Lee, can you address the surface preparation question?
Sure. What is the question?
Okay.
Oh, sorry. What kind of substrates did you test, and what was the surface preparation?
Right. For this data, for the lap shear strength, this was performed on anodized and primed aluminum, and then just cleaning with acetone.
Thank you. Next question. Will these adhesives work with composites?
Yes, all of them will. Absolutely.
Okay. Do you have any test data on environmental aging and/or fluid submersion?
Since these are aerospace products, these are tested for performance after immersion in your typical aerospace fluids, such as Skydrol or hydraulic fluids. So we do have that data that we can share with you.
Thank you. You commented about EpiBond 300's improved handling and EHS characteristics. Can you elaborate on that?
Yeah, thanks for asking it. One of the features of this product when customers approach us about developing the next generation liquid shim adhesive was they asked for a more similar viscosity for the mixing of the adhesive. The idea behind a more similar viscosity is it helps reduce the potential for the material to be splashed on the worker who is actually doing the blending should they be mixing it by hand instead of dispensing it from a cartridge.
Thank you. All right, next question. Will you also talk about how to apply storage conditions and restrictions regarding the transport of each material?
Okay. Thanks. For the storage conditions are stated. They're pretty straightforward. They're on our technical data sheet. These products were designed at the time they were created to be REACH compliant. And storage conditions, all of these are able to be stored at room temperature. None require refrigeration.
Thank you. How do these adhesives behave under tensile loading?
Lee, I think that's a good one for you.
We do have that data. They perform well, but we could maybe share that with you offline.
You guys are making my job easy here. Will EpiBond 300 reach shown 200 degrees centigrade characteristics without any elevated temp post-cure?
Lee, I think that's another good one for you. You did all the cure profile testing on it.
Yes, it will.
Okay. Our samples
but remember, keep in mind that, I'm sorry, I was just going to add that, just keep in mind that,
yeah, please.
Also that when the part does see that higher temp, that does actually cure it some as well. Just keep that in mind.
All right. Next question. Are samples of EpiBond 215 available?
Yes. We have a new production run of EpiBond 215. Samples are currently available in cartridges, I believe.
Okay. Great. Thank you. Do you have products suitable for non-aerospace applications? I'm involved with construction equipment, so high strength at ambient temperatures is important.
Yeah. Thank you for asking that one. While these are products designed for aerospace applications, they can certainly be used for non-aerospace applications, and we have a whole family of adhesives that are high performance that are designed for industrial applications as well. And that while they may not carry the aerospace pedigree, so to speak, they are certainly suitable for very high demanding applications such as construction equipment.
Thank you. Do you have products available for non-aerospace application? Oh, wait, I just asked that one. Sorry. I'm tripping over myself here, not making your job any easier. Please discuss bonding mismatched TCE components.
Lee, I think that's a great one for you.
Can they clarify, did you say TCE?
TCE, yes, sir.
I'm not sure exactly what they're talking about. Sorry. Maybe we can follow up with them on that one.
Yeah.
We'll be glad to follow up with that person that asked that question. We'll pull that one in offline and respond to them. Good question, though.
Excellent. How effective are your adhesives as a galvanic corrosion prevention layer between dissimilar material pairs?
I'm glad somebody asked that question. That's an outstanding characteristic of adhesives, and these adhesives that we just introduced today, as well as numerous other adhesives we offer, can greatly help reduce galvanic corrosion. I don't know, Lee, do you have anything else you want to add about the insulative properties of these, so far as galvanic corrosion is concerned?
Well, yeah, that's true. I mean, but when these materials cure, the epoxy matrix actually forms as an insulator for that, just as a coating would.
Judging from the way the questions are coming in and the level of interest, you guys did an excellent job on the presentation. Anyway.
Thank you.
Are there differences between autoclave cure and oven cure?
Lee, can you address that one?
As far as the performance that you would get out of it should be the same.
All right. Do you have TML data for outgassing on any of these products?
We do. So Epibond 215 is low outgassing, and we tested that recently. The TML is 0.91, so it does meet the E595 NASA requirement.
Thank you. For metal bonding, what primer do you use to pair with your paste adhesive?
There's several that you can use. Go ahead, Todd.
No, I couldn't recall what the last coupons that we discussed in the lab were primed with. Yeah. Is there a particular one that you go with?
I mean, you could use the Cytec BR 127. If you want to etch and prime, or
okay. What is the storage life at room temperature?
Good question. Which adhesive are we looking at?
It doesn't say.
Okay, it's a very fair question, a good question to ask. I'll address that for all three products. For the Epibond 200, it's 1 year at room temperature, and we're calling room temperature roughly 75 degrees Fahrenheit, but it could be as high as 104 degrees Fahrenheit. So 1 year for it. For Epibond 215, 1 year as well. And for Epibond 300, I believe we've given it 1 year as well at the same room temperature. Actually, I take it back. Epibond 215, we've gone as far as 18 months if it's refrigerated, and 1 year at room temperature.
Thank you. Do you know the tensile elongation percentage for 215 and 300?
You stumped me on that one. I got to give that one to Lee.
The elongation, we have the elongation for break for at my fingertips for Epibond 200. For 300, I think I will have to follow up with you on those. But we have tested those in tensile.
All right. Thank you. A metal prep question. How was the metal prepared and priming? What did you do for that?
So we had a third party. We purchased these third party prepared, anodized and primed aluminum. Just a standard aerospace type surface prep.
Thank you. To get maximum bonding performance, is oven cure always better than RT cure?
I believe yes, it is. It is better. It's faster. You can achieve your full properties faster, and you can push the final cure a little bit farther to maximize your properties. But as I said earlier, if a part sees a high temperature in use, then it will it might push it a few percentage farther as far as cure.
Thank you. One of our attendees wants to know, what are the densities of these adhesives?
All right. I'll grab that one if you want me to, Lee. That the density, if
Okay.
we're going to start out, say, with Epibond 300, Epibond 300, your mixed density is 1.3. For the Epibond 215, I believe our mixed density for that product is 1.1, and Epibond 200 is 1.3.
Thank you. Are the TDS available online yet?
Most are published online. If they're not currently online, we'll be glad to send them over to you. Just drop us a note.
Thank you. Well, that's all the questions we've received so far. I'd like to thank Mr. Holder and Mr. Eleuterius for giving us such an enlightening presentation, and I'd like to thank today's attendees for participating. That concludes today's webinar, sponsored by Huntsman Advanced Materials and TechBriefs Media.